So guys, going forward, now next we will going to understand the concept of local subnet and remote subnets. It is very important to understand what are local subnet and what are remote subnets in order to understand routing. So remember, point-to-point links, there are always two devices in a point-to-point link, and those two devices forms exactly one subnet that I have already explained in the previous slide. So you can see that there are two point-to-point links and each point-to-point link forms one subnet. So let us call this as subnet A and the other subnet as subnet B. Now let us read. So a set of interface of devices interconnected with one another and has IP address configured such that all of them falls have same network ID forms one subnet. So let us analyze what this definition is saying. This definition has two parts. That a set of interfaces of the devices are interconnected with one another. This is part 1. And the part 2 is that those interfaces are assigned an IP address such that all those IP addresses falls in the same network ID. This is the second part. So both parts, that is part 1 and part 2, is necessary and sufficient condition for the two machines or two interfaces of two different machines to fall in one subnet. Let us try to apply this definition in our topology. So a set of interface of devices. So we have two devices, VM2 and VM1. VM1 has an interface, let's say the interface is IF1, and VM2 has an interface, let's say the interface is IF2. Now these interfaces are interconnected using wire. This is wire, which we call it as point-to-point link. So the condition 1 is satisfied, that there are two devices and the interfaces of the two devices are interconnected by wire. Second condition is that the interfaces should be assigned an IP address such that both falls in the same network ID. So as I have already explained, if you apply the subnet mask value 24 on an IP address of the interface, you will get the network ID, which is 192.168.1.0/24. Similarly, if you apply the subnet mask value 24 on an IP address 192.168.1.1, which is an IP address of interface IF1, you will again get the same network ID. So the condition 2 is also satisfied. That is, the IP address of all the interfaces which are interconnected falls in the same subnet, computes the same network ID, and therefore falls in the same subnet. So when the condition 1 and the condition 2 is satisfied, we say that the device VM2 and VM1 are in same subnet. Why they are in the same subnet? Because they have at least one interface which are connected by wire, and the IP address and mask value assigned to those interfaces are such that same network ID is computed by applying the mask on those IP addresses. Now, going forward, a subnet can be local or remote, but relative to a given router. So no subnet is absolute local or remote. Every subnet is either local or remote relative to a given router. So let us try to understand what this means. Now let us go through the definition of remote subnets. A subnet A.B.C.D/m, where m is the mask value, is said to be the remote subnet relative to router X if none of the local interface of router X has IP address configured which falls in subnet a.b.c.d/m, right? So this is the definition of remote subnet. Let us try to apply this definition to our topology. As I said, this is the subnet A and this one is the subnet B. So subnet A is a remote subnet for router VM and subnet B is a remote subnet for router VM2. Now why? Let us apply this definition and you will get your answer. So subnet A is a remote subnet for router VM. Why? Because router VM has no interface on which IP address and mask value are configured such that after applying the mask value on an IP address, the network ID A is not obtained. So in our topology, router VM has only one interface, Ethernet 2, and which is assigned the IP address 192.168.4.2/24. And if you apply the mask value 24 on this IP address, you will get the subnet ID B. So were you able to get network ID A from any of the local interface of router VM? The answer is no. And that is the reason that subnet A is a remote subnet for router VM. Let us consider a scenario. Suppose router VM had another interface and the IP address configured on that interface is 192.168.1.10/24. Let us assume. Now, is subnet A still remote subnet for router VM? The answer is no. The subnet A is no more a remote subnet to router VM. The reason is that the router VM has at least one local interface on which IP address and mask value are configured such that if you apply the mask value on an IP address, it will give you the network ID 192.168.1.0, which is network ID of subnet A. And therefore, we will say that subnet A is now a local subnet to router VM and no more a remote subnet. So I hope you understand the definition of remote subnet clearly. Now let us try to understand the definition of local subnet. A subnet a.b.c.d/m is said to be local subnet relative to router X if at least one of the local interface of a router X has an IP address configured which falls in a.b.c.d/m subnet. So that is very easy. So the router VM has a local subnet B. Why? Because router VM has at least one local interface which has IP address and mask value configured such that if you apply the mask value on that IP address, you will get the network ID of subnet B. So we say that the subnet B is a local subnet to router VM. Similarly, subnet A is a local subnet to router VM2. And subnet A and subnet B both are local subnet to router VM1. Why? Just apply the definition and you will get your answer. Both subnets A and B are local subnet to router VM1. So it is very important that you understand how to identify a given subnet as local subnet or remote subnet with respect to a given router or given machine. This will lay the foundation of your understanding of your L2 and L3 concepts. So let us see in this table, for a router VM, what is the local subnet? The local subnet is the subnet B. And what is the remote subnet? The remote subnet is the subnet A. And for the router VM1, what is the local subnet? Both A and B are local subnet. And there is no remote subnet. And for the router VM2, the local subnet is the subnet A and the remote subnet is the subnet B. So this is how we identify the local subnet and remote subnets with respect to a given router. Now, let us try to understand how to identify the local and remote subnets in case of a broadcast link. Now, what is broadcast link? A broadcast link is a wire through which more than two machines are connected. So how many machines are connected through this wire? Machine A, B, C, D, as well as the router itself. So such a wire is called broadcast link. On a link, when there are only two machines are connected on either end of the link, such a link is called point-to-point link, which we discussed in the previous slide. So you can see that in this diagram, each machine, that is machine A, machine B, machine C, machine D, are connected to the broadcast link through their respective interfaces, which have the MAC address MA, MB, MC and MD. Right? So what is the network ID of this broadcast link? To calculate the network ID of this broadcast link, just pick up any machine which is connected to this broadcast link and apply the mask value to the IP address of the interface through which the machine is connected. So let us pick up the machine A. So machine A is assigned the IP address 11.1.1.2/24. Just apply the mask value 24 on this IP address, you will get the subnet ID. The subnet ID is 11.1.1.0/24. Now, if you are facing a difficulty that how to apply a subnet mask value on an IP address, again we will discuss the IP address mathematics in detail. For now, just understand that if you apply the mask value on an IP address of an interface, you will get the network ID. So for machine B, machine C and machine D, if we apply the mask value on their respective IP addresses, you will get the same network ID. And this is true for router interface also. So the network ID of this subnet is 11.1.1.0/24. Is there any other subnet in this diagram? Yes, the another subnet is this. I have not shown you the rest of the topology on this side, but you can see that the router has another interface IF1 which has MAC address M1 and has IP address 10.1.1.1/24. If you apply this mask value on this IP address, you will get 10.1.1.0/24, which is the subnet ID or network ID of this link. So things to note here is that for a router, each interface lies in different subnet. So for a router, the interface IF2 lies in 11.1.1.0/24 subnet and the interface IF1 lies in 10.1.1.0/24 subnet. So for L3 router, this is L3 router, each interface of an L3 router always lies in a different subnet. This is misconfiguration if two or more than two interfaces of the same router falls in the same subnet. This is misconfiguration. So guys, let us now discuss the local and remote subnets with respect to this topology. So you can see in the table, I have mentioned what are local subnets and what are remote subnets with respect to a machine present in the topology. So you can see with respect to the router has two local subnets, 10.1.1.0/24, that is the subnet this one, and the subnet 11.1.1.0, that is the subnet configured on interface IF2 of the router. So you can see that both the subnets are local subnet with respect to the router, and there are no remote subnet with respect to the router. Similarly, for each of the machines that is present in this topology, you can see that the local subnet for each of the machine is 11.1.1.0/24. That is, this shaded region is a subnet and this subnet is 11.1.1.0/24, and this subnet is a local subnet with respect to the machines A, B, C and D. Why they are local subnet? Just apply the definition of local subnet and you will know, right? Because each of these machines has an interface which lies in this local subnet, right? Hence, this subnet, that is 11.1.1.0/24, is a local subnet for machine A, B, C and D. Whereas the subnet 10.1.1.0/24 is a remote subnet for all of the machines, that is machine A, B, C and D present in the topology. Why it is a remote subnet? Because none of the machines, that is A, B, C, D, have interface which is configured with any IP address that lies in this subnet. Therefore, this subnet is a remote subnet for machines A, B, C and D. So I hope by now it must be crystal clear how to identify a given subnet is a local subnet or remote subnet with respect to a given machine.